All right, so we're back with Connect Day 2. This is the part of the show you've all been waiting for. We're with the C++ team, or members of the C++ team, which also had announcements yesterday that were pretty profound and excellent. You can play with them in the latest build of Visual Studio 2015. Please introduce yourself.
So I'm Ayman Shukri. I'm the Group Program Manager for the Visual C++ team.
Hi, I'm Ron, and I'm a Program Manager on the C++ team as well. I focus on graphics tools for DirectX.
My name is Arthur Lagsberg. I'm a development lead for Visual C++ libraries team.
Cool. And for those people out there who have used PPL tasks and stuff, look at the face.
I participated in the development of that, yes.
So let's start off right off the bat. What are some of the top-end announcements you guys made yesterday?
So yeah, we announced preview, obviously, to 2015. There are multiple streams or main streams that we had this release. The number one thing, and I believe Ankit from our team spoke about it earlier today as well, is the cross-platform device development.
Yep.
So in preview, you can be able to have shared C++ code that you can target for Windows and Android as well. So that's one of the major items that we've been working on for the last year,
Excellent.
at least. In addition, of course, we continue our investments in the C++ conformance. And the preview compiler is one of the most VC conformant compilers. And we'll talk more about it as well, hopefully, today. The other parts as well, one of the main pillars of this release is actually the throughput or compile time improvements. It's one of the things that customers in general have been talking about. With the bloating of the libraries and people's sources actually becoming bigger, it became a bigger problem for us to actually make sure that we actually invest in this area.
Absolutely.
And we've got a number, very good numbers, ranging from 3x to 10x improvements.
Awesome.
On the compile time. As usual as well, we continue investment in our libraries and as well as our compiler backend and code generation, taking advantage of vectorization, new hardware, provide guided optimizations and all this kind of stuff.
Cool. Keeping Eric and his team busy.
Absolutely.
Right on. So let's talk briefly about something I know I'm excited about personally, the awaitable functions. Can you talk through that?
Yeah. Thank you, Charles, for asking. This is actually a great question. We actually have a demo right now. Let me go straight to the demo, and I'll explain things as we go. Thank you.
This is not rehearsed, by the way.
Is it that bad, really? So let's imagine that you are having a function that returns numbers, gives numbers to you asynchronous. Let's say you're reading something from a TCP stream, right? And naturally, this function returns you not a number, but a task of a number, right? And if you want to start reading numbers from that stream and printing them on the screen, the most natural way for you to do it would be to do it like this. You call the function, and then you call get on that function. That blocks the calling thread and retrieves the value out of the task. So this is nice and easy, except that it actually blocks your thread. So if you want to put it in your GUI application, your GUI thread will block, and your user is going to see a spinning donut. If you put it in a server application, then it's not going to scale because you're blocking threads. So this is where you want to use PPL. And PPL is nice and easy to use as long as you're composing things sequentially, right? You have an operation, you want to perform another operation. After that, you call .then. Things are nice and easy. But as soon as you start doing something more complicated, for instance, you're trying to create any kind of iterative structure that's just like a loop, things become a lot more complicated. Look at what I'm doing here. I'm calling, I have a special case for n equals 0. And then every time I need to get a new number, I have to invoke this function recursively, right? This is getting complicated. And this is, even in this case where this is a very simple example, I have to write a lot of code. There is a lot of ceremony going on. Managing state is very complicated, but it works. Now, let's look at how we would do it in a feature called await. Now, you'll notice that you'll see there's some red squiggles, and so this feature is still experimental in preview. We've released it. We want to get it out because we want to get feedback. We want to get bug reports. We want people to experiment and see how it works. So you have to put up with some of the things like squiggles. look at how nice and natural this code looks, right? Instead of calling the .get on the function, I'm simply calling await. And I can still use my tried and true for loop and iterate through the list of numbers and print those numbers sequentially. So we think that this is going to be a big improvement for anybody who is writing asynchronous code. If you're using PPL today, you should be very excited about await, because this is going to be a massive improvement over the PPL.
Awesome.
Right, thanks.
Great, man. No, actually, it's brilliant. It's like, the question I would ask you is what comes out the other end? So the implementation of this, is it going to be less code?
It's going to be less code, yes. Yeah, it's going to scale, but mostly the wins are productivity. You can always write your state machine yourself in C and C++, right? But it gets increasingly complicated as the complexity of your program grows. With await, you just continue to write what looks like sequential code, and it just scales. You're as productive as when you're writing a sequential synchronous code.
Excellent, man. That is a wonderful feature. And we're going to try to get this into the ISO language, right?
Yeah, we're working on that.
Cool. So people out there, wake up. I know if you're actually a C++ developer, you're maybe rolling out of the rack right now after a long night of coding and then some drinking. But wake up and ask some questions. We have the right people here to answer them. So let's move along to PICs. I believe that's what it's called.
Yes.
Let's talk about GPU debugging.
Right. So in Visual Studio, one feature we already have is called graphics diagnostics. Just think of it as a debugger for graphics. So this is mainly for if you have a rendering issue in your app, in your game, like color is wrong, or my object is not rendering, or it's rendering wrong. That tool can really help you figure out what was wrong. You can go and capture, I can actually show you where to find that tool, which is under debug, graphics, and then start diagnostics. From there, you can capture frames, and then you can inspect every single DirectX call that you have made in that frame, and then inspect all the information, pixel history, pipeline, all that to figure out what was wrong. Cool. So that feature is there, and we made a number of improvements to that in the preview release. On the other side of the graphics apps which is performance. So there are times where your graphics app is all running fine, looking good, but it's just not running fast enough. In a lot of games, we're targeting like 60 frames per second on PC, and sometimes on smaller devices, might be targeting 30 frames per second. There will be cases where your app is not hitting that target frame, and you really want to understand what is causing the performance problem and how I can fix that. So we're adding a brand new tool in Visual Studio 2015 preview, as well as 2013 update 4, called GPU usage. And you can launch that through, again, debug menu, and then say start diagnostics tool without debugging. If this is 2015, if you're using 2013, the menu name is slightly different. I believe it's called performance and diagnostics, but it does the same thing. Basically, this brings up the Diag Hub page, which lists out all the features, all the tools that you can use. And now we have added this GPU usage tool into that list. Basically, you can use that tool to understand, what exactly is going on the GPU and the CPU when my app was running.
Great.
So let's actually launch this tool and see what it does. What I have here is a DirectX application, and I'm going to just select that tool and start. This would launch my app. So right now, this app is doing pretty well. But I want to show you what the Visual Studio actually is doing here. So go back to VS. You can see live your frame time, how long each frame took to render, frame rate. Like right now, it's hitting 60, and your GPU utilization percentage, how busy your GPU is. And then let's stop collection and see what else we have collected.
Okay.
We actually, under the cover, our tool is collect a bunch of information from the graphics driver, so that we can show you exactly how long each DirectX call took on the GPU and CPU. So from here, it's the same graph that we have seen live. Additional information you can see from here is if you select a range in the timeline, And for this app, it's running pretty flat, so you can pick anywhere, and then hit View Details.
Okay.
This is going to generate a GPU detail graph. So let's take a look at the table down here first. Basically, this is a list of all the DirectX events that were executed on the GPU when your app was running. So we collect event name, when did it start on the CPU, on the GPU, how long it took for the GPU to render that particular event,
Okay.
and then which thread, which core, which engine it was executed on. So it's a bunch of information that we actually collect from the graphics driver. And then up here, you can think of that as a visual representation of the same data down in the table. So we break down the graph into CPU cores, GPU engines, so you can see what event is happening on which core or which engine. So all these blocks are showing the execution time. The color stands for different processes. In this case, it's red for the app I'm profiling. And then you can interact with it. You can click anywhere on the graph. And then, for example, here I've selected a draw event. And then you can see that it's also selected in my table down there. And it tells you, oh, this is how long it took for the GPU to render, to execute. And this is when the API call actually happened on the CPU. So you can actually see that core relationship. The other thing you can learn from here is, I want to mention these vertical lines here, these light gray lines. These are actually representing VSync time of your display. So usually your display is set to 60 refreshes 60 times per second. For your app to hit 60 frames per second, basically you have to finish, CPU and GPU both have to finish all the work for each frame within 16.6 milliseconds. That's how much time you have. This is basically what these lines are standing for.
Okay.
So between these two lines, it is 16 milliseconds. So for all the CPU, GPU work to finish, you can use those lines as a reference point to see, hey, is it my CPU taking too long or is it my GPU taking too long? That's how you can understand, well, is it my CPU the bottleneck or the GPU is the bottleneck?
Great.
So yeah, you can use this tool to understand exactly what's happening to help understand performance issues.
Perfect. Really, really useful for game developers, obviously.
Yeah, for DirectX games and apps.
So that brings up a question, though. So only DirectX is supported.
That is correct.
Okay.
So far, yes.
Come on, man. What's going on here? All right, I'm joking. but I understand. I mean, this is the new Microsoft, right?
Right.
In the past, that would be like, of course, yes, but you never know.
I mean, we're open for the feedback.
Right on.
Right.
So give us feedback. Keep asking questions too, like now. So let's go back to Await, and Jose wants to know, how does it help performance?
So, Await is about three things. It's about developer productivity first, right? You write less code. Your code is easy to understand. It's easy to write, easy to maintain. That's number one. Number two is Await lets you write very scalable code. You can have an application with thousands and millions of pending awaits, and it will continue to scale, right? And finally, it's about responsiveness. You can write await in your GUI application, and your application continues to be responsive. Your GUI thread is always alive. So depending on what you call performance, right, it could be a number of things. It could be scalability and throughput and responsiveness, and Await gives you all three. The good thing about Await is that you don't really have to think twice before using it, right? If I use it, right, what's going to be the overhead? Should I really use it? Should I not use it? Just use it. It's great. It scales. It's very cheap. It's probably
And
as cheap
we're
as a
working as
function
well. I mean,
call.
our back-end team, code generation team, is working as well with the
Yes.
front-end team to make sure that whatever code we generate for it is actually as performant as what's expected from us.
Absolutely.
Sure.
This is a joint project between the compiler, front-end team, libraries, and back-end
Yep.
team. A lot of people came together to put it together.
And you guys also did work, like the people who implemented the feature, I know, on to limit code size of the feature itself and the output binary.
This is also one of the things people should be excited about. Compared to PPL, if you use PPL today, you might experience some code bloat, especially with C++ CX. Await just takes care of that.
Cool. All right. So Stefan, that's not STL. That's someone else's name, Stefan. So there's-
Stefan knows
there
the
can
answer to
only
that
be
question.
one.
It's a question.
Stefan knows the
Yeah,
answer
yeah,
to that
yeah.
question.
So will there be support for C++11 UTF char types in 2015, i.e. char 16_T and char 32_T?
Yeah, the quick answer is yes, there will be, but I would encourage you to go to our blog, and we regularly publish the conformance table with features where every feature is explained in detail, and we tell you what feature is coming, what feature is not there, is still not there, which feature is coming. So
But
it's,
yes,
it's
the
all
answer,
there.
the answer is yes.
Cool.
So,
Right on. So Josie wants to know, will the GPU usage chart be available with VS Community Edition?
Yeah, great question. Actually, it's already in there.
Great.
In the 2013 version. The other thing I forgot to mention earlier is we actually support desktop apps, Windows Store apps. Phone apps will be support will be coming later. It's basically because we need the latest driver to supply this information to us.
Okay.
But yeah, all the platforms, Microsoft platforms, will be supported.
Awesome. Rob wants to know any progress in the 2015 preview on the compiler conforming to the current C and C++ standards. So there's a C in there, not just C++.
Let me start with C++
We can do that.
first, okay?
let's actually as well show them the,
Great idea.
yeah, we have here.
There you go.
Excellent.
Actually, I think that's the, yeah.
This is the one that's not secret, right?
No, it's not. This is actually Herb Satter's famous slide. But actually, the next part is actually interesting. This is the one that we actually have those features in C+11, C+14. The green ones that actually were targeted, it's actually in preview, all of those.
Great.
The blue ones, that's ones in our plate. At least we have a good plan, engineering plan for them to be out in RTM time frame. This is not all the features, but we're working on other stuff to make it happen as well. I don't know, Arthur, if you want to add something as well.
No, I think you pretty much covered it, yes.
That looks great. And what about C? Yeah.
Yeah, our investments in C standard in general has been driven really by the unblocking some of the famous libraries that need the C99 standards as well. We actually have been working we enabled some in VS 2013. We're open if you have specific same strategy. If you have specific features that are blocked for some specific famous libraries, we're more than happy to.
And I would also add that we have enabled C99 library support. So all,
Sure.
all the functions that were missing in the previous releases are now there, almost all of them.
Cool. I mean, the point, I guess the moral of the story is C is still a language that's evolving. Lots of people are using it. It's a very important language. And you guys are, I mean, the C++ is steeped in history with C. I mean, look at the experience we get for build time and linking and all that wonderful stuff, right? So, meeting C++, welcome, man. Thanks for coming. How was this feature handled in the C++ committee meeting in Urbana? Will this make it into C++ 17? I'm assuming he's talking about await.
Await, yes. Yeah, great question. So Gordon Ishanov, who is the main architect and the developer of the await feature, has presented it on Monday. It has received a lot of support. A lot of people are very, very excited about it. I would say that the committee is very interested in seeing it in the next version of C++, whether it's going to be C++ 17 or the next version of C++, we don't know yet. Typically, things go into a technical specification first, where multiple vendors are encouraged to implement and experiment, and then moving from technical specifications to the standard proper. So we are just, we are continuing that journey, and we'll see where that leads us.
Awesome, man.
And I guess there's a question before about the XP
Yes,
support.
so XP, can never get rid of it.
Yes. And the answer is yes. In VC 2015, you'll still be able to target Windows XP.
Great.
So it's in the box. We will have the SDK that for XP that you can actually just change your tool set. You still use the newer compiler and everything. It's just a normal Windows SDK that targets XP+.
Hey, man, I mean, you know, XP is a great operating system.
Oh, yeah.
And, you know, having worked on it and whatnot, I'm proud of what it is, and I'm glad we still support it.
Yes.
At least you guys
Yeah.
support it. There may be critical security vulnerabilities, but you know you can still compile your code and run it on.
Yeah.
All right, so let's see. Jürgen wants to know: are there further improvements made or planned for very large C++ solutions? The amount of time it takes to load, and then IntelliSense to catch up, etc. In this release and debugging and stuff. So giant, like let's say Windows is a pretty big code base.
So yeah, so we are doing a number of like IDE improvements for scalability for loading bigger C++ projects. We've had actually a number of improvements in load time. especially in IntelliSense as well,
Yeah,
and
IntelliSense as
and refactoring as well. We have tons of new features that we've done there. We might want to even show some of this stuff.
Yeah. Thank you for asking.
Yeah.
We actually have a demo we
Awesome.
can show you
Yeah.
here. All right. So in 2015 preview, we built in a number of productivity features to help you be even more productive when you're when you write C++ code. So the first feature, let's start with the simple one. I'm going to show you is refactoring rename. So I have a header file here.
I don't think we're capturing that.
Uh,
Live.
That's weird.
It's actually getting.
Are you?
it's
I
getting,
don't
Oh.
think we're capturing it.
it's getting the different.
Try. Maybe it's extending.
Extend.
Oh, yeah.
Yep.
Perfect.
Okay, there we go. All right. So I have a header file on the left side, and it's source file on the right side, just to show you. So I have this class called CDemo project doc, and it has a number of functions in there, including serialize. On the CPP side, we have the implementation of that method. We also have other function calls that's using that serialize method. Let's say you want to rename this function to be something else. Now you can just right-click and select rename. You can give it whatever, serialize super. You could also pick different options in here. Let's say you want to do not only references but also comments or any strings in your code. You can select that as well. But for now, we're just gonna click OK, and this is gonna populate a preview dialog. This basically shows you, okay, this is a preview of how your code will be changed. So you can navigate through and see if this is really what you want. You can actually toggle each one of them, and if you see something you don't want, you can uncheck that, and we will not make that change for you. If I scroll down all the way, there are comments. We also find that. There are strings in your code. We also find that because we didn't check the options, so they are not checked by default. If I do apply, you can see this has
Great.
been renamed. Also, we output actually all the changes we have made in your code, so you know what has happened to your code. You can double click to navigate. I believe it's on this side. Now, this is actually a function call that's using serialize super.
Great.
Now, that has been renamed as well. So that's rename. Let's go back to you can also undo all the changes at once. If I do Control Z, everything will be gone, back
Great.
to normal. Let me show you some other features in here. So this is a different class. So basically, I have one class called iComputable, and just to resize this a little bit. Here I have 3 functions. These 2 are pure virtual because they don't have any implementations. And iKnown does the same thing. I have 2 pure virtual functions. And then I have this class, which is inheriting from multiple classes, including iComputable and iKnown. And because both of them have pure virtual functions, this class is going to have to implement all of them.
Mm-hmm.
So instead of you going there and typing every single function, now you can use this feature here called refactor and implement all pure virtuals for this class.
Nice. Excellent.
And then once we do that, let me show you what has happened. So here in the header file, we add all the declaration in here. And what's showing up here that's embedded is actually a feature called CodePeek. This is showing you what has happened to your CPP file. So you can preview the results in here. And we also have the CPP file open on the other side if that's easier to look at. So we can compare the results.
Great.
So these are the definitions, these are the declarations. So that's one feature. And the other thing you might want to do is sometimes you want to move all of your definitions into your header file, like doing inline functions. You can actually do that using our new feature called refactor and move definition location. So here I am moving these functions from the source file to header and see what happened. Everything has disappeared on CPP file, but they have been inserted into my header file. See all these functions? They actually have the implementation being in line as well.
Great.
So these are a few predictive features. The other feature that we have seen a lot of asks for is extract method. That's also a popular ask. So we actually didn't ship that feature in the preview build, but we did ship an extension on VS Gallery that you can download and install on your machine. So let me show you real quick. It's under Tools, Extensions, and Updates. And search for extract. Online. Extract. There you have it. So it was
Great.
made available yesterday. Feel free to download that and install on your machine. Once you do that, you can now extract anything here. Let's say I have this function, and I have some code in that, and I decide I want to move this code into a different function. I can select all the code and say extract method.
Okay.
Give it some name. C compute super. Okay, and it's all done. So we added a new function down here, and then we replace it with the new function name.
Cool.
There you have it. You
Very
have
nice.
various refactoring features. You can try it out.
Very cool.
Great. Great to see that.
And of course, in addition to all of that is for bigger projects as well, we spoke about the build time in general. And I think we've had tremendous improvements. And I'd love actually as well to show here some of the major improvements we've done in build time. Like those are actually real examples of using our new compiler. So we've worked with, for example, some of the internal projects like Epoch and Forza and the VC compiler itself. And this is, for example, this is some of the linker times here. We've had from 10x, 2x, and 3x faster. I mean, we multi-threaded the linker, incremental LTCG. We've done a number of improvements with the PDB writing algorithms. So you should, and we have actually a fully now detailed blog as well about the exact improvements we've done. So
Awesome.
definitely try it. Let us know. That's one of the main pillars as well for larger projects.
Absolutely. I mean, build time is important.
Absolutely,
Right.
absolutely.
So not everybody has a terabyte, gigabyte machine, and or terabyte machine with ungodly amounts of power. So beautiful.
Yep.
All right. So Nick T, is Const Expert going to be supported in Visual C++ 2015?
Yeah, I can take that. The short answer is yes, it's going to be supported at the C++ 11 level of support. We are somewhere between C++ 11 and C++ 14. The generalized Const Expert is kind of difficult to implement, but we're still working on it.
Right on. So Shen's question is really not for this team since you're not the Windows team, but we should still talk about it because one of our MVPs is working on something very interesting for ISO C++ targeting the Windows runtime. That, of course, being called Modern CPP. And that's going to enable you not to have to use C++ CX, which,
Right on.
if all the work is being done by him and is sort of a compiler infrastructure that's not really a compiler. But the moral of the story is, for C++ developers that don't want to use C++ CX, at some point they're not going to have to with this tool that's going to be written by one of our MVPs. Anyway, but we should talk about that. So have you guys made any advancements, any changes, any improvements to the CX stuff? So targeting the Windows runtime, have you made any improvements? Or
We've made some improvements a little bit to the code size of C++ CX, and
Yeah.
actually started with the VS updates.
Cool.
But not anything major more than this. We are looking as well in general, not the WinRT, but even actually it's a good segue for the unified CRT work that the team has been doing. So one of the areas as well that we improved is not WinRT related, but more of we've heard from some customers saying, I have different libraries, it's built with different runtimes. Why do I have to deploy different versions, different runtimes? All I'm using is printf. Like, why do I have to use the different stuff? And we've been working with actually the platform team, Windows in that case, to actually integrate our C runtime to the stable component and the stable component that's evolving.
Great.
The stable component is the one that we're driving to be actually part of the platform itself.
Nice.
So if you're using that stable part that haven't been changed for a long time,
Mm-hmm.
there's no need for you to really deploy anything with your app. Windows becomes your really runtime at that moment.
That's awesome.
So that's something that's starting from VS 2015.
Great.
And we're working with the platform to see how we can make it down level as well.
So does this mean that, so for example, if I'm writing an app that will target WinRT 8.1, I don't have to include the Visual 2013 C++ runtime package SDE extension in the future?
Correct.
Okay.
That's the idea.
Cool,
That's the
because
idea.
you'll get weird things at runtime, not deploy time when you don't include it.
Of course,
obviously.
it depends on. We broke down our C runtime to different areas.
Okay.
So as long as you're in the area that's in part of the platform, like think about it, it just becomes a platform API that you're just calling.
Perfect. Right on. Johan wants to know, is there any ongoing work on implementing an undefined behavior sanitizer for Visual C++?
We don't have a tool called undefined behavior sanitizer, but we approach it from multiple angles, right? We have static analysis tool that can pinpoint places in your code where you potentially are having undefined behavior. We have runtime checks and stuff like that. So, yeah, we are making definitely some efforts in that area.
Excellent. Leo, any plan to support code metrics in 2015 native code? Code metrics.
So is that more about how many lines and all stuff like this, or?
Well, I think in Visual Studio you can right-click Tools, Code Metrics, and then something happens. I actually don't use that tool.
Yeah.
I don't know, but
Yeah,
I guess.
I don't know.
Yeah.
To be honest.
Sorry, man. Keep the great question. Ask on a blog. Will DirectX be ever open source? Does Microsoft plan this in the future? Again,
That's a great question for Windows.
Yep.
Yeah.
Where's the Lesh? I'll check.
Knowing where we're at right now, what we've seen what's happening in .NET framework and stuff, I wouldn't take anything off the plate. That's the new Microsoft. You'll never know.
Hey, yeah, absolutely, man. And I guess we're going to be winding down here soon, and at least that's what I've been told by the producer. There's nothing in my ear. But do you have any more questions? I mean, have we missed any of the topics that you guys did? So we talked about link time speed, new features for productivity, await being them at the language level,
Yeah.
which is rock and roll. I'm sure STL has been busy optimizing and
Absolutely.
cranking
Yes.
and fixing bugs. Yes?
Absolutely, yeah.
Okay.
And we've talked earlier about cross-platform mobile development. We've integrated Clang LVM toolset into VS to target Android and hopefully other platforms as well coming. You're still using C1C2, our VC compiler for Windows platforms, and then Clang LVM for non-Microsoft platforms.
Sure.
And I would also mention one other library that we want to talk about is Casablanca. Casablanca
Great.
has been a cross-platform library from day one. We supported Windows and Linux from the beginning, and then added support for OS X and iOS and Android. And what's happening in this release is we actually are enabling you to target Android from within Visual Studio. And the latest version of the Casablanca hasn't been released yet. The team is working on it literally as we speak. But check back with our blog in a day or two, and you'll see the latest release where you can actually use it as part of our multi-device development story.
Awesome. Excellent. So we have some more time, so we're going to take some more questions. Thanks for asking. Chris wants to know, any plan to support mscripton in VC++? Essentially translate C++ to JavaScript to run in browser.
So I know, don't take it granted from me, but I know there's been discussions in the team. There's been more than once raised. There's nothing concrete about it yet, but so no concrete plans of doing that right now. But there has been raised discussions. It's more into the JavaScript team as well.
Sure.
We know more in this area. But yeah, I would love to ask them as well. We defer
Sure.
that to them.
And so Inscriptum, of course, for people out there who don't know, that's exactly what it does, right? It takes C++ code and generates ungodly amounts of unreadable JavaScript that is then used. And there's another library that's used. We should talk to the JavaScript team.
Yeah.
I know those guys are into that idea.
Yep.
The other thing we haven't mentioned yet,
Yes.
which is a brand new tool in Visual Studio 2015, which is a memory profiler for native C++ code now.
Excellent.
So it's also available in the diagnostics hub I showed earlier, where you can find GPU usage tool as well, where you can also see a memory usage tool
Great.
that you can use to understand, well, are there any objects leaking in my application? Yeah, it's great for desktop apps, store apps. You can try it out and let us know if that
So
works for
that
you.
brings up an interesting question. So the WinRT API is a native API. Everything's written in C++, in terms of like what you use as a consumer programmer. So if you're using the WebView control, the XAML WebView control, that's implemented in C++. That's a native control that you're then using from your WinRT app. If there's a memory leak or something's happening with the WebView that you're using, can I use the memory profile? And I've written my app in C#, and I'm bringing in all the web junk, the web stuff, the images, the videos, and all that stuff in the JavaScript. I'm noticing some strange memory behavior, and effectively in the native part of the application, which will be what's going on a lot of it underneath. So can I use a memory profile then to kind of peek and understand what's going on with native memory?
We actually have memory tool for all languages, and for C++, for C#, for JavaScript. Depends on which part in your code you want to look at. You should launch different tools.
Sure.
Like if you know it's C#, it's also called memory usage.
Okay.
You can launch that. I think JavaScript has a memory consumption tool as well that you can launch separately.
Sure.
But yeah, it's all covered.
It's all covered, except that sometimes it's really hard to figure out if your app isn't native, right? A C# app isn't native, but it uses a heck of a lot of native memory. It
Now
can.
you have a native tool.
Got it. Hey, all right. So Shen, have you considered modernizing libraries such as ATL to take advantage of the performance improvements enabled by C++11?
We are making incremental improvements in libraries like ATL and NMFC. Most of them are driven by customer feedback. Whenever we have a connect bug, we go and fix that. And when we fix that, hey, we can now use C++11 so we can do things better, right? But we are not planning any significant overhauls of libraries like ATL and MFC. And one of the reasons for that is that it's very difficult to modernize a library without breaking backwards compatibility. So for instance, if you want to introduce things like move semantics into MFC or ATL, this would be pretty hard to do without actually changing how it works. So we want to be careful there, not to break existing code and kind of improve it as we go, but not do anything drastic.
Cool. And so Greg has a question that I can't necessarily see, but it looks like it's going to be about resumable
Okay,
functions.
okay.
There was an option of declaring the function itself resumable.
Yeah, this is a great question actually, because the design team went back and forth whether we need to have a resumable function or not, and a resumable declaration or not. And in the end, what we settled on is that the compiler can actually see your function, and you can see a weight inside your function. So why force people to tell what the compiler already sees, right? And so we've decided it just looks nicer without resumable. And so this is how it's going to ship in the preview release in RTM.
So that brings up an interesting question as far as design. So in the C# implementation, you have to mark any function as async.
Correct.
Why don't I have to do that in C++?
Because the compiler actually sees your code. The compiler can see a weight in your code, and the compiler can kind of deduce it for you. Oh, this function is actually resumable because he is using a weight.
But if I were a caller of said function, then if I had an async in front of it, I would know as calling into your library that it's an async function.
Oh, and the thing is, it doesn't matter. You don't have to know, right? You're calling a function that gives you back a task or a future, right?
Okay.
You don't need to know how it's implemented. Resumable is the fact that a function is resumable is just an implementation detail. That's another good reason to actually not have it as part of the function type, right? Consumers don't need to know.
Okay, right on. You don't need to know, huh?
You don't need to
What are you going to do? All right, so Stefano's back. Can you maybe say anything about the future release cadence of Visual C++ beyond the 2015 release, in particular with regard to language conformance, where support for full expression,
FinRay, yep.
seems to be the biggest missing feature?
So we will continue releasing on a quarterly basis as a VS updates. Those VS updates will include newer features to the conformance, provided that none of them are actually breaking changes. So one of the major pillars we have is you install an update, you need to still have your code compiled as expected and run as expected without changing behavior or at compile time as well. And as people are expecting that. So yes, some of the actual conformance features are more of opt-in features that actually doesn't affect your existing code. Those we have, or we're planning right now, we're building an engineering plan of how to actually make them available through the updates.
Excellent.
Yes.
Cool. So Ariel wants to know any improvements in debugging tools for parallel programming support like AMP, which we haven't discussed, OpenCL, or CUDA?
So we haven't done any debugging improvements in C++ AMP, but we have done some compile time improvements and runtime improvements. So if you're compiling a large parallel for loop in C++ AMP, there's a good chance it's going to compile faster and run faster as well.
Yep. And the other part as well, we've worked with our partners to make sure that C++ AMP as a programming model available for non-Microsoft platforms as well.
Absolutely.
So right now, C++ AMP underneath is DX if you're on Windows, and it's OpenCL underneath for actually other platforms.
Great.
And actually, we have published this as well, and should work with 2015 and 2013 as well.
Cool. And I can use the GPU tool, can I? It's not just graphics. It's whatever going on the GPU. So if I have an AMP problem,
You could
Okay.
use it, but you might want to have additional annotations for C++ AMP programs.
Right
so
on.
that's something we can do in the future.
cool,
Planning.
for the general purpose
Right.
case. So what strategy do you propose to manage project dependencies in native apps? Having to handle manually include paths is a pain. Any kind of Maven for C++?
So there's one word for this: modules. Please follow our efforts in ISO C++ committee, where we also are pursuing this improvement in C++ together with our partners. Modules.
So will modules replace the need for header files?
Pretty much, yes.
Awesome. What does that mean for the linker? Anything? Everything?
Obviously, the linker will have to undergo some changes.
Yeah.
The compiler, the whole compilation chain is going to
Awesome.
need to change.
Let's see. Roman wants to know, as you relative to Intel C++ compiler, I think that might mean.
I guess
how
the
are
question
you
is, what's the
doing
relationship between
Yes.
the compilers? Two completely different compilers, not related in any way.
Okay. David wants to know, any plans to help monitor CPU cache misses within C++ apps? Wrong?
No, no
Nothing-
plans at
no
the moment.
plans yet.
Yeah.
But
That's the kind of feedback we're waiting
yeah.
for, right?
Great.
tell us a
Great
bit more
feedback,
about
yeah.
your scenario, what you would like to enable, and we'd love to hear back from you.
Awesome. And you guys actually do a really amazing job of taking customer input and then really delivering on what they're asking for. I mean, the C++ team has always been, at least in the last 10 years,
Yeah.
ears to the ground, listening, reacting. So excellent work, man. And it's nice to see Jose's back. It's nice to see we have a clan of people that are asking great questions.
Yeah.
Any work has been done for direct OpenGL implementation?
This means the OpenGL implementation on Windows,
Yes.
right? That would be a great question for actually the
Windows
OS
team?
group.
The Windows
Yeah, OS
DX
group
team.
Yeah.
can say.
One Microsoft, man. We can speak
Yeah.
for anybody now. Let's see. OpenGL. I think, whatever. That's a great question, but ask
Yeah.
the Windows people, man. And keep on asking questions. If you don't have any more, we can continue to be a little bit random, which is always fun. What are some of the things you guys are working on for the next wave? Like, not what are you going to deliver, but what are some of the big picture items that you want to tackle for the next wave?
I think we want to understand, still number one priority is in VS in general, is we're shifting to targeting other platforms as well. You want to understand your needs. Obviously, we've been receiving some questions about, now in preview you've done Android and Windows. How about iOS? It's something we're trying to build a plan for right now from a C++ perspective. There's the other questions as well. Do we do anything for Java? Do we do anything for Linux and server stuff? All this kind of stuff are actually on the table for consideration, and we're trying to figure out what's the right thing here. And we're getting we want to enable something. We threw out something. We want to collect feedback, and based upon that, that's going to determine our next behavior. Obviously, we'll continue investing in the standards, so they keep
Absolutely.
evolving. We'll continue investing in that area. There are some other questions as well about how you're going to bring Clang LVM for Windows, not just non-Microsoft platforms.
Yes.
That's still something that's not off the table. It's on the table for consideration. Some customers are asking for it. So I wouldn't be surprised if we start looking at it in a more serious considerations.
Excellent.
But yeah, we're heading I believe we're heading in the right direction. We need our customers to guide rail us to the right area.
Just one more thing to add in the graphics area. One thing we've been working on is the graphics tools to support DirectX application, the DirectX 12 applications.
Okay.
That's going to be the next generation of DirectX APIs. More low level, you have more flexibility to make it faster, to make your apps faster. So our debugging and profiling tools is going to completely support running the DirectX 12 apps.
Great.
So
And
that's
of
gonna
course,
be next thing.
and of course, we will continue to innovate in the language and library space. Things like await, modules is on the horizon. So definitely keep your eyes peeled.
Great. I mean, it would be nice to see a day where the legacy of the past can be completely removed from the language perspective
Yeah.
and still be backwards compatible, right? That's the hard problem. But
Yeah.
it would be so nice to be able to read C++ as easily as you can read C# and get all the benefits
Absolutely.
of C++,
Yep.
the power, the low-level control. Let's rock and roll. So we have a team here. The Connect has ended, and it's great to end it with the C++ team. And for all of you out there, thanks for watching. And big kudos to everybody in DevDiv
Thank
and
you, guys.
Visual Studio. I mean, what an amazing release, amazing announcements. .NET is open source.
Yep.
The server core, etc. Amazing new tools. Roslyn is now actually powering the IDE experience for C# and
Yep.
VB. You guys have done great work.
No,
as well.
we're really excited
Cool.
about this release. So thank you all.
Cool.
Thank you.
Take care, everybody.
Thank you.
Thanks for watching. Download the preview.